Another trigo combination commonly involved in trigonometric transformations is tangent secant. Check how to find the antiderivative of this type of function here in integral calculus. As shown in the previous video, there are common identities which are helpful for integrations, such as the reciprocal identities, ratio identities, Pythagorean identities, double angle, and identities of products. What are the usual tricks in integrating a tangent-secant combination? If the exponent of secant is an even number, put aside secant squared to reinforce the derivative. Then use Pythagorean identities to express the remaining secant into tangent. The other possibility to look for is if the exponent of tangent is an even number. For this case, separate the combination of secant and tangent, then use Pythagorean identity to express the remaining tangent into secant. Example 1 requires the antiderivative of secant squared x, tangent cube x dx. First is to take secant squared as a part of the derivative, and check on tangent cube x as secant squared x dx is the derivative for tangent, which is included in the integral. So take u as x, where du is dx, then n is 3. And since the test already shows compliance of the components, there is no need to transform any part, but integrate using simple power formula instead. That would be tangent of x raised to 3 plus 1 over 3 plus 1 plus c. Simplify this to have tangent of x raised to 4 over 4 plus c. The second example looks for the integral of secant y raised to 4 times tangent cube of y dy. Adjust the function by extracting secant squared as part of the derivative. So now we have the integral of secant squared y tangent cube y with secant squared y dy. Next is to use Pythagorean identity to transform the remaining secant squared. Starting from sine squared of u plus cosine squared of u as 1, divide each term by cosine squared of u, making tangent squared u plus 1 as equal to the square of secant u. This is the transformation to be plugged into the integral, now having the quantity of tangent squared y plus 1 times tangent cube y secant squared y dy. With the addition operation between the terms, distribute the integrand, and get the integral of tangent y raised to 5 times secant squared of y dy plus the integral of tangent cubed y with secant squared y times dy. These terms already seem familiar according to the list of trigo integrals, so take a closer look on each in an attempt to use power formula. For the first term, take u as tangent of y, where the derivative of tangent y is secant squared y dy. This is the term exactly considered as the derivative, so there is no need to balance anything at this point. N is also 5. The second term has u of tangent y, where the derivative is secant squared of y times dy, exactly what is with the term itself, so there is no need to adjust on the second term as well. N is 3. So through simple power formula, we integrate the function as tangent of y raised to 5 plus 1 over 5 plus 1 plus the tangent of y raised to 3 plus 1 over 3 plus 1, then add c. Simplify the addition and get tangent of y raised to 6 over 6 plus tangent of y raised to 4 over 4 plus c. The next example has tangent of x raised to 5 dx for the function to be integrated. Since the exponent is odd-numbered, extract one tangent function. Our goal is to come up with the secant tangent as the derivative for secant. So the function becomes the integral of tangent x raised to 4 with tangent x dx. Now transform the remaining tangent using Pythagorean identity. Again, it is easy to derive the relevant identity from sine squared u plus cosine squared u as equal to 1. If each term is divided by cosine squared, the function becomes tangent squared u plus 1 as equal to secant squared of u. As we are to transform tangent, jumble the terms to have tangent squared as secant squared of u minus 1. Place this into the function to have the integral of the square of secant squared of x minus 1 times tangent of x dx. To be able to separate the terms later, expand the square to have secant of x raised to 4 minus twice of secant squared of x plus 1. With minus and plus appearing in the function, we can now distribute the integrand and have the integral of secant x raised to 4 tangent of x dx minus twice the integral of secant squared of x tangent x dx and add the integral of tangent of x times dx. The next step is to analyze each term. Starting from the last term, there is no direct integral of tangent x with only dx as the derivative, so use ratio identity to make the third term as the integral of sine x over cosine of x dx. From the adjusted function, take out one function with secant x to be a part of the derivative in the first and second terms. So the whole function now becomes the integral of secant cube x with secant x tangent x dx minus twice of the integral of secant x times the derivative with secant x tangent x plus the integral of sine of x over cosine of x dx. With the three terms, analyze their components separately with the attempt of using power formula. The first term has u of secant x, where the derivative is secant x tangent x dx, and n is 3. The second term has u of secant x. du is secant x tangent x dx, and n is 1. The third term has u of cosine x, where du is taken as sine of x times dx. Take note that u is in the denominator, and the derivative is found in the numerator, a specific characteristic of logarithmic integration. With no further adjustments required, integrate each term and have secant of x raised to 3 plus 1 over 3 plus 1 minus twice of secant x raised to 1 plus 1 over 1 plus 1 plus ln of cosine of x plus c. Simplify each term and have the final integral of secant of x raised to 4 over 4 minus secant squared of x plus ln of cosine of x plus c. Example 4 requires the antiderivative of sine cube of x dx over cosine x raised to 6. Initially, transform both functions to find the common function. Start with the transformation of sine of x. From ratio identity, tangent of x is sine over cosine of x. So sine of x is tangent x cosine x. Then continue with the transformation of cosine as 1 over secant x using reciprocal identity. So sine of x is tangent of x over secant of x. The other term to transform is cosine of x, with reciprocal identity, making it 1 over secant x. Place these transformations into the integral and have the cube of tangent over secant of x all over 1 over secant of x raised to 6 with dx. Distribute the exponents among the terms and get tangent cube of x over secant cube of x, and these are divided by 1 all over secant x raised to 6. Secants can be reduced, making the function the integral of tangent cube of x times secant cube of x dx. With odd-numbered exponents, extract a function each and get the integral of tangent squared of x times secant squared of x with secant x tangent x dx. Then the same procedure of converting the remaining tangent into secant using Pythagorean identity, having tangent squared of u plus 1 as secant squared of u. Extract tangent squared of u as secant squared of u minus 1. This is plugged into the integral and have the quantity of secant squared minus 1 times secant squared of x with secant x tangent x dx. From the function, distribute the integrands to create two terms which include the integral of secant x raised to 4 times secant x tangent x dx minus the integral of secant squared x secant x tangent x dx. The two terms can now be analyzed for complete components. U of the first term is secant x, and its du is secant x tangent x dx. N is 4. The other term has u of secant x, just the same with du as secant x tangent x dx, and its n is 2. Both terms can be integrated using power formula, that is, secant of x raised to 4 plus 1 over 4 plus 1 minus secant x raised to 2 plus 1 over 2 plus 1, and then add c. This is then simplified as secant x raised to 5 over 5 minus secant cube of x over 3 plus c. The next example is with the antiderivative of secant w raised to 4 dw. Factor out secant squared as part of the derivative, making the function secant squared of w times secant squared of w with dw. The extracted secant is the derivative for tangent, so the remaining secant should be transformed into tangent using Pythagorean identity. That is, secant squared u is equal to tangent squared u plus 1. The function then becomes the quantity of tangent squared of w plus 1 times secant squared of w dw. Next is to distribute integrands among the terms, now becoming the integral of tangent squared of w secant squared of w dw plus the integral of secant squared of w dw. Analyze the components of each term. U is tangent squared of w. Du is secant squared of w dw, and n is 2. The second term has u of w. Du is dw. With the derivatives fit for the integral, we can integrate using simple power formula. That is, tangent w raised to 2 plus 1 over 2 plus 1 plus tangent of w plus c. So the simplified integral is tangent of w raised to 3 over 3 plus tangent of w plus c.